All right, the outer planets. In the 1840s, astronomers were puzzled. Uranus didn't move as expected based on the theory of gravity. Astronomers John Couch Adams and Urban Leverrier independently hypothesized that Uranus was being affected by another planet's gravity. They calculated where this planet should be. Another astronomer, Johann Galle, aimed his telescope at the place Leverrier predicted. On September 23, 1846, he discovered the new planet Neptune. All right, work with a partner to answer the question. What science skills did the astronomers use when they discovered Neptune? Okay, what did the outer planets have in common? If you could visit the outer planets, you wouldn't have a solid place to stand. The four outer planets are much larger and more massive than Earth, and they do not have solid surfaces. Because these four planets are so large, they are often called gas giants. Figure 1 summarizes some basic facts about the gas giants, and Figure 1 is this chart over here we'll get to. All right, composition. Jupiter and Saturn are composed mainly of hydrogen and helium. Uranus and Neptune contain some of these gases, but also ices of ammonia and methane. Because they are so massive, the gas giants exert a very strong gravitational force. This gravity keeps gases from escaping, forming thick atmospheres. Alrighty? Despite the name gas giant, much of the material in these planets is actually liquid because the pressure inside the planet is so high. The outer layers are extremely cold because they are far from the sun. Temperatures increase greatly within the planets. Alright, moons and rings. All the gas giants have many moons, ranging from 14 around Neptune to more than 60 around Jupiter. These moons vary from tiny balls of rock and ice barely a kilometer across to moons larger than Mercury. Some of these moons even have their own atmospheres. In addition, each of the gas giants is surrounded by a set of rings. A ring is a thin disk of small particles of ice and rock. Saturn's rings are the largest and most complex. All right, over here, the outer planets. Earth's diameter is about 12,750 kilometers. About how many times larger is Jupiter's diameter than Earth's? Use your chart to answer that question. All right, characteristics of each outer planet. Since telescopes were first invented, scientists have studied the features of the outer planets and their moons. Space-based telescopes and space probes, including the Voyager and Galileo missions in the past and the Cassini mission today, continue to reveal many new details of these planets and their moons. All right, Jupiter. Jupiter is the largest and most massive planet. Jupiter's enormous mass dwarfs the other planets. In fact, its mass is about 2.5 times that of all the other planets combined. Jupiter's atmosphere. Like all of the gas giants, Jupiter has a thick atmosphere made up of mainly hydrogen and helium. One notable feature of Jupiter's atmosphere is its great red spot, a storm that is larger than Earth. So, a great red spot is a storm that is larger than Earth. The storm's swirling winds are similar to a hurricane, as you can see in Figure 2. Unlike hurricanes on Earth, however, the Great Red Spot shows no signs of going away. All right, Jupiter's structure. Astronomers think that Jupiter probably has a dense core of rock and iron at its center. A thick mantle of liquid hydrogen and helium surrounds this core. Because of the weight of Jupiter's atmosphere, the pressure at Jupiter's core is estimated to be about 30 million times greater than the pressure at Earth's surface. All right, so looking at Figure 2, the Great Red Spot. This storm is about 20,000 kilometers long and 12,000 kilometers wide. The largest tropical storm on Earth was 2,200 kilometers across, so calculate. Think of the storm on Earth as a square and the Great Red Spot as a rectangle. About how many of your squares would fit inside the rectangle? All right, Jupiter's moons. Galileo discovered Jupiter's largest moons in 1610. These 4 moons, known as the Galilean moons, are named Io, Europa, Ganymede, and Callisto. Over time, astronomers have discovered dozens of additional moons orbiting Jupiter. Many of these smaller moons have been found in the last few years thanks to improved technology. From time to time, Io, Europa, and Ganymede line up, causing a stronger gravitational force. These forces make their orbits more elliptical. All right, the Galilean moons. Jupiter's 4 largest moons are larger than Earth's moon. Each has characteristics that set it apart from the others. So based on the photograph, match each description below to its moon. So these are the pictures of the moons here. You're going to read the descriptions, and then you're going to match the name with which one you think it goes with. So, Ganymede. It is Jupiter's largest moon. It is larger than Mercury. Its surface is divided into dark and bright areas. Callisto is second to Ganymede in size, but has less ice. It has the most craters of any of Jupiter's moons. Io is not icy, unlike most of Jupiter's moons. It may have as many as 300 active volcanoes. The eruptions from those volcanoes constantly change the moon's surface. Europa is covered with ice. There may be liquid water below the ice, and if there's water, there might be life. Okay, the Saturn system. Recent space probes have shown details of Saturn and its moons. So make judgments. Would it be easier to build a space colony on Saturn or on one of its moons, and why? And then challenge. Look at the photographs of Mimas and Tethys. What can you infer about the history of these moons? All right, Saturn. The second largest planet in the solar system is Saturn. Saturn, like Jupiter, has a thick atmosphere made up of mainly hydrogen and helium. Saturn's atmosphere also contains clouds and storms, but they are less dramatic than those on Jupiter. The Cassini space probe found unusual six-sided cloud patterns around Saturn's north pole. Scientists aren't sure what causes these patterns. Saturn's rings. Saturn has the most spectacular rings of any planet. These rings are made of chunks of ice and rock, each traveling in its own orbit around Saturn. From Earth, it looks as though Saturn has only a few rings and that they are divided from each other by narrow, dark regions. Space probes have shown that each of these obvious rings is divided into many thinner rings. Saturn's rings are broad and thin, like a compact disk. Some rings are kept in place by gravity from tiny moons that orbit on either side of the ring. All right, Saturn's moons. Saturn's largest moon, Titan, is larger than the planet Mercury. It is also the only moon in the solar system that has a thick atmosphere. The atmosphere is composed mostly of nitrogen and methane. Some of these gases break down high in the atmosphere, forming a haze that is somewhat like smog on Earth. In 2005, the Huygens probe landed on Titan's surface. Photos from Huygens showed features that may have been formed by flowing liquid. A few scientists think that Titan might support life. Scientists have learned a great deal about Saturn's moons from the Cassini space probe. Giant craters and trenches cut across the Mimas and Tethys ice. Giant craters and trenches cut across Mimas and Tethys. Ice and water erupt in geysers from the surface of Enceladus. In 2009, scientists discovered a ring of material that may come from the outermost moon, Phoebe. Figure 3 shows some of the members of the Saturn system. Okay, so all of these pictures on here are showing you different moons and things about Saturn. Down here, eruptions from, we say that Enceladus, eruptions from Enceladus form one of Saturn's rings. What is that ring most likely made of? All right, Uranus. Although the gas giant Uranus is about 4 times the diameter of Earth, it is still much smaller than Jupiter and Saturn. Uranus is twice as far from the Sun as Saturn, so it is much colder. Uranus looks blue-green because of traces of methane in its atmosphere. Like the other gas giants, Uranus is surrounded by a group of thin, flat rings, although they are much darker than Saturn's rings. All right, the moons. Photographs from Voyager 2 show that Uranus's 5 largest moons have icy, cratered surfaces. The craters show that rocks from space have hit the moons. Uranus's moons also have lava flows on their surfaces, suggesting that material has erupted from inside each moon. Voyager 2 images revealed 10 moons that had never been seen before. Recently, astronomers discovered several more moons for a total of at least 27. All right, a tilted planet. Uranus's axis of rotation is tilted at an angle of about 90 degrees from the vertical. Viewed from Earth, Uranus rotates from top to bottom instead of from side to side as other planets do. You can see the tilt in Figure 4. Uranus's rings and moons rotate around this tilted axis. Astronomers think that billions of years ago, an object hit Uranus and knocked it on its side. Images from the Voyager 2 space probe allowed scientists to determine that Uranus rotates in about 17 hours. So it's kind of standing up and down versus side to side, or it's kind of side to side versus up and down like we would think Earth is. All right, so how do day and night at Uranus's equator change as Uranus revolves around the sun? All right, Neptune. Neptune is similar in size and color to Uranus. Neptune is a cold blue planet. Its atmosphere contains visible clouds. The color comes from methane in the atmosphere. Neptune's interior is hot due to energy left over from its formation. As this energy rises, it produces clouds and storms in the atmosphere. Neptune's atmosphere. In 1989, Voyager 2 flew by Neptune and photographed a great dark spot about the size of Earth. Like the great red spot on Jupiter, the great dark spot was probably a giant storm, but it didn't last long. Images taken 5 years later showed that the spot was gone. All right, the moons. Astronomers have discovered at least 14 moons orbiting Neptune. The largest moon is Triton, which has a thin atmosphere. Voyager 2 images show that the area of Triton's south pole is covered by nitrogen ice. All right, changing Neptune. The photograph above was taken in 1989. The photograph below was taken in 2002. How did Neptune change? All right, apply it. Congratulations. You've earned enough AU in your travels to qualify for a free mission to one planet or moon of your choice. Which planet or moon do you choose? List 3 reasons for your choice. What is one question you would want your mission to answer? All right, and for the assess your understanding, describe one property of each outer planet that distinguishes it from the others.